Beneath every modern road network is a system that most people rarely notice. Stormwater drainage works quietly in the background, helping to protect traffic movement, road safety, and the long-term performance of urban infrastructure. Underpasses present a particular engineering challenge. Because they are positioned below the surrounding road level, rainfall naturally moves toward their lowest points. When surface collection or underground conveyance cannot manage that flow, water can accumulate rapidly. Traffic may be interrupted, road conditions may become unsafe, and critical infrastructure may be placed under increasing pressure. At this underpass in Casablanca, stormwater is collected through kerb-integrated inlets positioned along the roadway. The lateral openings allow surface runoff to enter the drainage system, while accessible covers provide entry to the collection chambers below. From there, the water follows a controlled drainage path. It moves through the kerb inlet, enters the collection chamber, and continues through underground pipework toward the wider stormwater network. But reliable drainage depends on much more than the inlet visible at the surface. Every part of the system must work together. The road gradient guides the water. The inlet receives it. The chamber collects it. And the underground network carries it safely away from the roadway. Engineers must therefore evaluate the complete drainage environment before selecting an appropriate solution. Rainfall intensity, contributing catchment area, road geometry, inlet capacity, underground pipe capacity, traffic loading, and maintenance accessibility. Each factor influences how the system will perform during real operating conditions. Even a well-designed drainage system can gradually lose performance. Sediment, litter, and road debris may restrict the movement of water and reduce hydraulic capacity. Accessible chambers make regular inspection possible. They allow cleaning, sediment removal, and corrective maintenance before minor obstructions develop into larger operational problems. Maintenance is not separate from drainage design. It is an essential part of long-term infrastructure resilience. Across Casablanca, continuing investment in roads and mobility infrastructure is increasing the importance of reliable supporting systems. Public information from Casa Management and LE360 provides wider context for these ongoing urban improvements. As cities continue to expand and rainfall places greater pressure on urban roads, these hidden engineering details become increasingly important. Effective drainage helps road infrastructure remain safer, more serviceable, and better prepared for changing environmental and operational conditions. Mert Fonderie develops drainage, access, and infrastructure products for demanding urban and industrial applications. Supported by engineering knowledge, manufacturing capability, and a long-term commitment to durable infrastructure solutions. Because resilient infrastructure begins with the systems designed to protect it.